We're going to skip some of the discovery just to save on time. You guys are writing down, or you already wrote down a formula that's going to have us, help us, show us how to find the determinant of any size. We should already know how to find the determinant of a 2 by 2. How do we do that? A determinant of a 2 by 2. AD minus BC, or main minus opposite, diagonals, right? AD minus BC, that's how we do 2 by 2s. 1 by 1s, we saw at the very end of yesterday. How easy are 1 by 1s? Very, because it's just whatever's in there. But determinants of 3 by 3s and above are a bit more complicated. Determinants of 3 by 3s and above are a bit more complicated. So I'm going to go ahead and show you how that works in an example. Then we'll come back to these 2 pages and fill in. So right now from this page, we know there is a formula for, anyone who missed yesterday or anyone who forgot, there is a special notation. Absolute value bars around a matrix means determinant. But the AD minus BC only works for a 2 by 2. So we're having to figure out how to find determinants of bigger things, bigger matrices. And there is a formula, but it seems kind of complicated from this page, right? The formula seems kind of complicated from this page. So let me go ahead and show you finding a determinant. First of all, I'm actually not going to find it with the formula yet. There is a trick for 3 by 3s. And I think this trick will be a good lead-in for how the formula works. There is a trick, but only for 3 by 3s. It's kind of similar to the 2 by 2 main minus opposite. It's kind of similar to that. But there is a trick that does not look like a CK, does it? Sorry. There is a trick, but it only works for 3 by 3s. So then after I do the trick to solve for the determinant, then I'll show you how the formula works. And then the formula works for 3 by 3s, 4 by 4s, 5 by 5s, any size matrix that you might have. P.S. If any of you guys are good at your calculator, you might want to go ahead and open your calculator, put this matrix in matrix A, because we're also going to talk about how to find determinants on your calculators also. Okay? So go ahead and get them written down. Get them put into your calculator as matrix A. And if you remember, for inverses, there's that little button because the programmer made the reciprocal button into an inverse. That's for inverses. But for everything else matrix, where do we go to do stuff to it, like REF or RREF? Good, matrix, and then go over to math. Matrix math. You guys should be able to see DET, like right at the very top, right? Okay, so if you guys plug in this matrix, I want you to go ahead and use your calculators to find DET of matrix A. And as you do that, let me orient this board, because it's going to be rough if it's going to be that far off. Okay. That was exciting. Okay, who got a determinant? What'd you get, Christina? 14? Okay. And I heard some of you guys back her up, yeah? That's what the determinant is supposed to be. Now, if this was a 2 by 2, we would do main minus opposite. But the problem is, if we did main minus opposite, are we going to get every element or every entry? No. So there's a shortcut for a 3 by 3, and the shortcut for a 3 by 3 says the following. The shortcut says, okay, just for 3 by 3s, since that doesn't cut it, what if we were to go ahead and kind of like put the matrix on a loop to where it starts repeating? And then we can actually have it repeat again, and we would only repeat the first 2 rows. Then I can have enough entries or enough elements to do main, but not just once. Do 3 different main diagonals. And just like with a 2 by 2, you would actually multiply those elements. So for the mains, you would end up with 0 times negative 1 times 1, which is 0, plus 2 times 2 times 4, what would that be? 16, plus 1 times 3 times 0, 0. There's all your mains. And then you would do minus, now it's time for the opposites. And the opposites would go back. There's 1, there's 2, And there's 3. And you might say, but the 3 got left out. Oh, he definitely didn't get left out. He's just being used somewhere else. And so for the opposites, we would go ahead and say, all right, what's 2 times 3 times 1? What's 0 times 2 times 0? And what's 1 times negative 1 times 4? When we put all of that together, we'd end up with 16 minus 2, which is done. Cool little trick for people that like mental math. For some of you, that's a lot of numbers to put together. But it does work for a 3 by 3 alone. 2 by 2, main minus opposite, easy. 1 by 1, whatever is in there. 3 by 3, we could rewrite the first 2 columns. I think I might have said rows, sorry. Rewrite the first 2 columns and do main, 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 minus, a big minus, opposite, 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 and you will get the determinant. It checked, right? It matched. 14 equals 14. But this doesn't work for anything bigger than a 3 by 3. So let me show you what this whole page and this whole formula was about that works for 3 by 3s or higher. Here's another way to solve. I want you guys to go ahead and write the matrix 3 times, not just once. Write the matrix 3 times, not just once. This method is going to be called expansion by cofactors. And that's what you guys wrote down in that little paragraph a second ago when you wrote the formula. Here's how to do it with expansion by cofactors, not just the trick. Not just the trick. If you notice, this matrix has just been written 3 times, 1 and 2 and 3. Can you follow the pattern? What do you think I'm going to do on the last one? I didn't show the pattern. What do you think I'm going to do? Circle 1 and cross out what? 0 and 2 and cross out? Good. The pattern for this formula is that you take an entry, or all the entries actually, of any row or any column. And that's what the words meant right here, circling 0 and then 2 and then 1. That's what the paragraph meant when it said the sum of the entries in any row or column multiplied by their cofactors. So here's an entry, and you just take, or you would take, all of the entries in any row or any column. And this one, we've taken all the entries from row 1. But we could have done row 2 or row 3 or column 1 or column 2 or column 3. Expansion by cofactors says choose a row, choose a column, and think about every single entry in that column. And the formula tells me take each of those entries. Take A11, take A12, take A13, and multiply by, okay, well now we have to figure out who we're supposed to multiply by. In the formula, doesn't it say A11 times C11? Who is C11? Let me explain it to you. C11 is going to be saying, once we've identified the entry that we're going to use, ignore that row and that column and ask yourself what's left. Whatever's left, you're going to go ahead and put into a determinant. Whatever's left, you're going to put into a determinant. And we're going to do that for every single one. Whatever's left, put into a determinant. Whatever's left, put into a determinant. Okay? These little pieces are, first of all the numbers in front, these are the entries. This is the entry from each row. This is what we would call a minor. Ooh, that's a word you guys just wrote down. This little piece is the entry. This little piece is its minor. So coming back on this page right here, didn't you guys write down minors a second ago? Okay, so where are the minors? The minors, oh, okay. Minors are whoever's resulting from whoever's left after you ignore a row and a column. So if I was to say who is M, Mn, we would look at the matrix, we would ignore that row, ignore that column, and take whatever's left and throw it in a determinant. So for this one that you guys wrote down, M11 says take 11, take 0, ignore his row, ignore his column, and write down what's left as a determinant. And so to find M11, technically you would actually go ahead and solve and say M11 for this example is going to end up equaling main, which is -1, minus opposite, which is 0. Sorry that my board's being kind of dumb. We'll blame it on the pi. So you would take the main -1 minus the opposite, which is 0, and you would end up with -1. That's the minor. Cofactor says, no, let's go one step further. Cofactor says, take that minor, take this piece, but you also have to think about where it came from. What was the entry, whose row and whose column you ignored, and what sign would need to be or would be in that place. So for instance, for this one, you took this first row, first column for your minor, so then you would need to attach to the minor that positive sign. So for the example up above, C11 would just be, hey, take that -1, multiply it by a positive, but guys, will multiplying by positive ever change the sign that's already there? And the answer is no. So the cofactor for 11 would be the exact same thing as the minor for 11. Bless you, bless you. But if I had taken it, for instance, of the second one, of number 2 instead, his minor, I would have had to attach or multiply by a negative, which would have flipped the sign. So really this whole positive, negative, positive means keep the sign, flip it, keep the sign, flip it. Flip it, keep the sign, flip it. And so it just alternates. You could write these down, you could memorize them, but do you guys see the pattern of what's going on? It's just alternating. And whether you go down or whether you go across, it's just going to be alternating in every single row, every single column. So let's get back to our example. So far, I have my entries. So far, I have my minors. What I need last is my sign for the cofactor. Ooh, that got small, and I'm so sorry. Sign for the cofactor. So whenever we do this process, we need an entry times a minor with a sign for the cofactor. An entry times a minor times a sign for the cofactor. So guys, this one, what sign am I going to consider for my cofactor? Positive, because I need to start, I always start at positive, but then what's this one going to have? Negative, so it's going to be subtraction, then what's this one going to have? Positive, addition. So to find the determinant of A, all I have to do is solve. And to solve, I say, well, 0 times anything is 0. Forget that. Minus 2 times, I need my determinant, so I need my main. A times D is going to be minus B times C. Careful, times 8. Then plus 1 times the main will be 0 minus the opposite will be -4. So if you guys notice, I'm going to end up with -2 times -5 plus 1 times 4, which equals 14. And that process will work for a matrix of any size, not just 3 by 3s. Trevor. Main, opposite, yeah. Mm-hmm. Sadly, no. Sadly, no. The very first time I taught it, I was like, okay, let's go 4 by 4. And I was like, it's wrong, because the calculator didn't check and we were right. It was a rude awakening. It only works for a 3 by 3. I wish it worked for higher, because I like that way, but it only works for 3 by 3s. So this is a cool trick for 3 by 3s. But if we need to go higher, or if it says expansion by cofactors, then we would need to solve with this method. So let's go ahead and, we have time. Let's see if you guys understand the idea of minors and cofactors, okay? Looking at this matrix, it's a lot smaller, so it's going to look a lot different. But there are only, well, there's only 1, 1. There's 1, 2, because first row, first element, first row, second element. Then I have second row, first element, and then second row, second element. Here's the crazy thing. Remember, a minor is whatever is left out when you ignore this row, this column. A minor is whatever is left out when you ignore this row and this column. The 1, 1 entry is 0. But I'm supposed to ignore the row and the column. What's left? 4. Negative 4, right? So when I look at 1, 1, which is this spot right here, when I look at this spot right here, the 0, I need to ignore that row, ignore that column, negative 4 is left. The cofactor would say, hey, take that negative 4 and multiply them by a positive. Well, does that change anything? No. So it's still going to be negative 4. The cofactor says, hey, keep them the same sign. All right, fine, I'll keep them the same sign. But the minor says, ignore that row, that column, take what's left. So when I go to this entry, guys, and I'm ignoring the first row, second column, what's going to remain? Yeah, ignore, 3 is left. But what's the cofactor going to do to that 3? It's going to make it negative because this entry is going to be plus minus. I need to make that 3 the opposite sign, so it's going to be negative times 3, which is negative 3. And negative times that positive 3, which is going to be negative 3. So if I ignore the second row, first column, what do I get? You see it? Yeah, I have to ignore. If I go to 2, 1 and ignore his row, ignore his column, 10's left. What's the cofactor going to do? Make it, what spot am I in now? Good. Oops. Make it negative. I need to alternate. Even though it's negative, negative, that's okay. Positive, negative, then I have to alternate to a negative. So I'm going to put a negative in front of that 10, which is going to flip the sign to negative 10. Then what happens if you go to 2, 2 and his row, his column? 0. For cofactor 2, 2, technically just so that we get the idea, what's in that spot is going to be a positive sign. So I keep the sign the same, but oh, well, what's a positive? What's anything times 0? Yeah. There we go. So minors, what's left when you cross out? Cofactors, take what's left and establish or put in a sign. Take what's left and then put in a sign. Kiddos, I'm just going to show you this next page. But we're going to actually end with the following page. This page basically gives us the idea, and it's going to happen in homework a couple times maybe. It's going to give you the idea that, yeah, in the last example, we chose the first row and we went all across the first row, but technically you don't have to go across the first row. You could go across the second row. You could go across the first, second, or third column. You could go across the third row. You could go across any row, any column, and this process will work, but you only need to go across one. So I'm going to write down 3 matrices. Instead of solving it 2 ways, we're just going to solve it 1 way. And since we've already done a row one, let's do a column one. Since we've already done a row, let's go ahead and do a column just so we have a practice with a column. But once again, we're only doing column 3 because they said to. Otherwise, we could have chosen whatever row, whatever column we wanted. We just have to go across one of them. So if I was to go across column 3, let me just start the process and give you guys a couple seconds to see if you can repeat. To start the process, I'm going to take the, I just oriented you. Come on. I'm going to take the first entry in the third column. I'm doing third column, taking the first entry. For my determinant, I'm going to go ahead and take that entry, multiply it by the determinant of whatever's left, and establish it with, well, hold on, plus, minus, plus. Okay, so I'm starting with positive. I'm going to multiply that 2 by a positive. But guys, am I done? No. What do I have to do to finish? Keep going down column 3. Ready, set, try to follow the pattern. Keep going. I started going down column 3. Can you guys finish going down column 3? Taking the entry times the remaining minor and putting it with the sign that's appropriate to what you're trying to solve. going to go slow. What sign did you guys put in front of the 1? Yeah. Does it make sense why a negative? What would be next? The negative would be next as you were going. Positive goes with 2. Negative must go with the next because they alternate. And then what's going to go with the last one? A positive again. What'd you guys circle for the last one? Good. Did you cross out the third column and the third row? Good. And did you get for that -8? -3, 4, 6, 3? Cool. Let me give you another 30 seconds to now go ahead and try to finish, because all you have to do to finish it off is just to do main minus opposite, right? 3 times. But solve for the little baby determinants of the 2x2s. Put it all together and then throw it in your calculator and see if you got it. We just have to do AD minus BC for each of these little 2x2s, each of these little minors. Main minus opposite, or AD minus BC. Then we're just putting it all together to solve. Oh, thank you, thank you, thank you. You guys doing all your main minus opposites? Then remember, you can go to your calculator. I'm hearing some of you to check it and see if you got it right. All right. I'm going to come and play. Double check me, but I think it's 151. Anybody in their calculator say yes? Great. I see a couple. Questions? Did I lose anybody? Zach? Oh, I did this just because I was following the directions when they said use column 3. So I said, okay, fine, column 3, I have to just start at the beginning and then go all the way down. I could have done that one for sake of time and because of all the fun stuff. I skipped that, but row 2, you would have just gone to row 2 and done the exact same thing, but with 6, 3, 1 instead. And instead of 2, 1, -8, you have 6, 3, 1. You would have had different remainders, different minors. And then the signs would be different too. Guys, real quick, if I had chosen row 2, what would the signs have been for 6 and 3 and 1? Yeah, 6 would have had to start at the negative, and then it would have had to go positive, and then it would have had to go negative. So depending on where you're choosing, you have to choose those signs appropriately. But otherwise, you'll be okay. So any row, any column that you would have chosen, as long as you had followed the process of the formula we saw at the beginning of class, Any row, any column, expanding by cofactors means take the entry, multiply it by the cofactor with the correct sign attached to the minor, and then you'll solve for the determinant. So we're not going to solve this one all the way out. This is actually where we're ending, and we're, I think, a couple minutes ahead of period 2. But they had a lot more kids, and they were a lot more excited about Pi Day and a lot more distracted. But good job, coming from behind. If you were given this example, and if it says choose any row or column that seems easiest to you, what do you guys think you would choose? Row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. Okay. That's kind of the same thing period 2 said. Some of you are like, hey, row 3, easy numbers, and a 0. But some of you thought a little further and said, oh, hey, column 3, because what's true of these two? So when you go to write this one out, let's see if you guys can get it. If I start with 6, hold on, what sign does 6 have? Positive, right? So if I was just to alternate, 6 is going to start with a positive. So when I start there, can you guys figure out what matrix is going to be left just to help me out real quick? Are you figuring out the cross out, take what's left, right? After we do the 6, what's going to be next? 3. Is the 3 going to have a plus or a minus? Minus. Okay. What's his minor going to be? 2, 6. Careful. 2, 6, 2. 1, 5. Why do you think some people would say choose column 3? What can you do next? It's just going to be 0 times and then plus 0 times. Right. Plus 0 times and minus 0 times. But all that's just going to cancel out because 0 times anything is 0. But here's the dilemma. And I'm just making sure that you guys see where you would go. You don't have very many of these in homework, but where would you go? How do I keep going from there? I can't just do main and opposite because it's not a 2 by 2 anymore. Isn't it a 3 by 3? Okay, I could do the trick. I could rewrite the first 2 columns again. And I could do main, main, main minus opposite, opposite, opposite for this guy and that guy. It's definitely possible. But let me just show you what else you could do without the trick. Couldn't you also put a big old 6 right there? And then couldn't you, I'm just going to choose this one because he's easier. Couldn't you keep going with the whole positive, negative, with the whole cofactor deal? And then couldn't you cross, 7, 6, 7, 7? Set it up for the row, which would be 2, 6, 3, 7. And then minus 1 times, because positive, negative, negative, positive, negative. When I cross, 2, 7, 3, 7. Couldn't I just treat this little 3 by 3 like his own little matrix and find a determinant that way? And that will get me this piece. I'd have to do little main minus opposites and then simplify all that, then multiply by 6. But what else would I also have to do? Do the same thing but with the 3. I like these numbers again just because they're nice and small. So I'd probably do the same thing with positive, negative, and negative 1 times. Now guys, will a lot of numbers be involved in the answer? Yeah. Would you have to be careful if you're doing it by hand? Very careful, right? But as long as you group things with like parentheses or brackets, as long as you're very careful in how you set it up, choosing your signs wisely, you could bring the 6 in first, but then you have to rewrite it all. As long as you go very carefully, you should be able to just follow the process and get where you need to go. I'm going to finish this off and writing it. Cross, 2, 2, 3, 7. And I'm back at the 1, and the 1's going to be a negative 2, 6, 3, 7. It would take a little bit of time, but all you need to do is simplify. Main minus opposites. Multiply by their little entries in front, and then multiply by 6 and negative 3, and then one big ol' addition. Only reason it's addition is because it was subtraction, adding a negative. It just kind of ties the two together. I don't want minus a negative. That would be totally wrong. With that, kiddos, let's go ahead and pause for today. We did reach the end of section 8 I think this just says, can you use, ooh, there we go. Can you use a calculator to find a determinant? And the nice thing is you guys have already proven that we can. There's one homework-ish help, but it was only a 2 by 2. And it just has to do with some algebra. So let's see if you're able to do that for homework due tomorrow. But for right now, we have some pi, yeah?